All right, Bridges, this is section 5.4. I think this is going to be a two-parter, so this will be part 1. Factoring by grouping and special forms. So this part of it will be the factoring by grouping portion, and then we'll talk about the special forms in the next video. Well, basically, factoring is taking an expression and breaking it down into things that are multiplied together called factors. And the most basic thing we need to come up with when we're talking about factoring is finding a common factor between terms. So the first thing I'd like to do, find the greatest common factor or GCF, if you will, greatest common factor of the following terms. So 6x to the 5th, 30x to the 4th, and 12x cubed. Well, what we can do is we can look at the coefficients and come up with the greatest common factor between those, and then we can come up with the greatest common factor between the x's or any other variables that there might be in the expression. So let's look at 6, 30, and 12 first. So between 6, 30, and 12, you got to ask yourself, is there a common factor, or is there something that divides evenly into 6, 30, and 12? And of course, the answer to that would be 6, because 6 divides into 6 one time, 6 goes into 35 times, and 6 goes into 12 twice. So the greatest common factor between those is 6. Well, then you got to look at x to the 5th, x to the 4th, and x cubed. And basically how that works is you're looking for the biggest number of x's that goes into all three of those. So that would be x cubed. And so the greatest common factor between these guys right here would be 6x cubed, because you put together the 6 and the x cubed. Now, to help you understand how the x cubed works, let's take a look at x to the 5th is like this. You got 5 x's that are multiplied together. X to the 4th would be 4 x's that are multiplied together, and x cubed would be 3 x's that are multiplied together. And as you can see, the biggest number of x's that's in all three of these would be 3. So there's 3 right there, there's 3 right there, and there's 3 right there. It can't be x to the 4th. Oh, there's a random bell. It can't be x to the 4th because there's not another x here that would be common, okay? There aren't enough x's to make this bottom one x to the 4th. So therefore, x cubed would be the common factor here. And basically, the reason why I had you do it like that is so that you could understand that if I have an expression like 6x to the 5th plus 30x to the 4th minus 12x cubed, I can factor out the common factor, and this would turn into 6x cubed, and then I would need to figure out what's left over. Now, when I factor out something like this, factoring is basically like division. It's like distribution in reverse. I stumbled on that word. So basically, I can look at, say, okay, if I have 6x to the 5th, let me get my magic pen here. Magic pen. What color is it? Let's make it yellow. Anything that I write in yellow, you don't have to copy. But anyway, if I look at this 6x to the 5th, and I divide this 6x cubed into it, basically I'm saying, okay, how many times does 6 go into 6? Once. That'd be a 1. Of course, the 1's understood. And then, if I take x cubed out of x to the 5th, as you can see, I've got this x times x left over, which would be x squared. Then it would be plus 6 goes into 35 times. And then if I take x cubed out of x to the 4th, I would have 1x left. So that'd be 5x. And then minus 6 goes into 12 twice. And if I take x cubed out of x cubed, I'm taking all 3 x's out, so that one wouldn't be there. I guess I could fix this so that the parentheses are in a better spot. But anyway, this would be the factored form of the expression I gave you. So let's take a look at a couple of those, and then I'm going to teach you how factoring by grouping works. All right, so if I have 24x cubed minus 32x to the 4th, one thing you might consider doing is you might consider, whoops, that's not a 4, that's a 2. Fail. All right, well anyway, one thing you might consider doing at this point would be to pause the video and see if you can solve this on your own and then compare your answer to mine. That would probably be the most effective way to do this, where you would probably learn the most. So, I look at the 24 and I look at the 32. So the 24 and the 32, and I could say, okay, what's the biggest number that goes into 24 and 32? The answer would be 8. I mean, worst case scenario, 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6, right? 32, you could make 32 1 times 32, 2 times 16. 3 doesn't go into 32. 4 times 8, and that's it. And then notice that the biggest number that they have in common is 8. So therefore, 8 is a common factor. And then I could look at x cubed and x squared, and the biggest number of x's I could pull out of that would be x squared. Now, if I take 8 goes into 24 3 times. If I take x squared out of x cubed, I've got x left over, minus, and then 8 goes into 32 4 times, and then x squared is gone. So this is the factored form of the expression I gave you. Here's another one. Negative 3x squared plus 12x minus 18. And you might notice that you can't take an x out of this because the 18 here doesn't have an x. But you can take just a number out. 3, 12, and 18 are all divisible by 3. And if you wanted to, since this leading coefficient is negative, you could always take out a negative 3. I think a couple of the problems on the homework ask you to take out a negative number. And basically what that does is that changes all the signs. So if I take negative 3 goes into negative 3 once, that'll just be x squared. Negative 3 goes into 12 4 times, so that'll be minus 4x. And then this would be plus 6. All right, so now we need to get into factoring by grouping. Now these first couple of things are going to look a bit artificial, because I kind of have to show you the mechanism before we dive straight into it. So factor by grouping. All right, so let's say that I had x squared times 2x minus 3 plus 4 times 2x minus 3. Now it's important to note that these two sets of parentheses match. If they don't match, then you can't factor this by grouping, or you need to go back and see if you can refactor it somehow. But since those two things match, what we can do is we can take that term and factor it out. So I can take that, it's like 2x minus 3, that goes in front, and then what's left over is whatever's left when I pull that away. So this would be x squared plus 4. It's almost like if I had x squared times smiley face plus 4 times smiley face. Hopefully you would agree that smiley face is common, therefore you can factor out smiley face like we did earlier in the lesson and end up with this. Well, it just so happens that smiley face is 2x minus 3. All right, let's try one more of this, and then we'll jump straight into factoring by grouping, like the full-fledged one. So, if I have 5x squared times 6x minus 5 minus 2 times 6x minus 5, once again, these two things match. So therefore, I can pull that out to the front. So that's 6x minus 5, and then 5x squared minus 2 is left over. By the way, this set of parentheses and this set of parentheses can go in the other order. In other words, I can flip-flop where these are written. Some people like to write the 5x squared minus 2 first. That really doesn't matter. All right, so how does this relate to actually doing this with an expression that doesn't have part of it already done? So let's say I've got x cubed minus 5x squared plus x minus 5. Well, as the name suggests, what you want to do is you want to group this. So I can group these first two terms together and then these last two terms together. Okay? And I'll look for a common factor. So on this first piece, I say, okay, what's the common factor between x cubed and 5x squared? And the answer to that would be x squared. Now, if I take out an x squared, I'll end up with x minus 5 because there'll be one x left over here. And then these will all be gone. Now, there is no common factor back here, so I'm just going to write plus 1 because I can multiply by 1, and that'll stay the same. All right. Well, notice that these match, and we're to a point where we were before. So, I can pull that out to the front and factor it like so. All right. One thing I neglected to mention about this is you should always look for a common factor amongst the whole thing before you start factoring completely. Now, if you observe here, there is no common factor because 2 doesn't go into 3, and 3 doesn't go into 4, and not only that, I can't take out an x because the 6 doesn't have an x. So once again, I group. The greatest common factor here is 4x squared. If I take that out, I got x minus 2 plus 3, x minus 2, and then that's x minus 2 times 4x squared